Alright, what's up guys? In this video, I'm going to pick up with some multivariable calculus, and what we're asked to deal with today is it says find the area of the parallelogram that has two sides that are adjacent, and they give us the two sides here, u and v. So we just need to calculate the area. So remember that the area here is just going to be equal to the magnitude of the cross product of u and v. That's how we get our area. So let's begin by calculating the cross product of the two vectors, and we use our matrix method. So we got what we have here. So it's going to be I, j, and k up here in our first row. And it looks like we'll have -5. We're missing a j, so we got to stick in a 0, and we got 4. And it looks like we're going to have 1, a 2, and another 2. And so what we got is, we'll eliminate the column and row containing I. So that'll give me 0, 4, 2, and 2. To tackle an I out there. Then it looks like if we eliminate the column and row containing j, looks like we'll have -5, +4, 1, and +2. Stick our j, and then we cancel out the column and row containing k. We'll have -5, 0, 1, and +2. And that's what we got. Then we continue with everything. So remember, just cross multiplying and subtract the products. So we'll get 0 minus 8 I, because 0 times 2 is 0, subtract 4 times 2, which is 8. And then we got minus. And it looks like we get -10 minus 4. We'll tackle our j out there. And looks like we'll get -10 minus 0 k. And so therefore the cross product here is going to be -8i. That's going to be plus 14j because we got two negatives. And then this will be minus 10k. So that's the cross product. Now we need the magnitude of the cross product of those two vectors. So we'll get another sheet. Okay. All right, so let's keep going with this here. And remember, that's just the square root of the sum of the components squared. So we'll take the components of the vector that we got when we calculated the cross product. And so that'll be -8 squared plus 14 squared plus -10 squared. Okay, so we're going to get 64 plus 14 squared, that's 196, remember? And then this is going to be plus 100. And I think that's 360, but let me check. And you want to make sure you're doing this. I hate giving this speech, but I think it's necessary. Yes, 360. I see a lot of students that don't take the opportunity to take their calculator and check and make sure their arithmetic is correct. That is very important for you to do as math students, to make sure you're doing that. I don't know who has driven the notion over the last couple of years that using a calculator is a bad thing, because it's not. And this exercise is relatively easy, but the biggest reason why students miss it is because they don't go back and check their arithmetic. Nobody's perfect. So it is not out of the realm of possibility for you to make an incorrect calculation. So please take your calculator and check your answers. Don't allow your professor to take points away from you. That's something that you can avoid. If you don't know how to solve the problem, that's entirely different. We can work on that. But don't let them take points away from you. Check your answers. Now, the square root of 360, if we take the square root of that, we're not going to get a whole number. Probably going to get a decimal. So, yeah. So what that means is we can do a little prime factorization. And 360, that's not too big of a number. That's just 2 times 180. We can break up 180 as well. That's 2 times 90. 90, that's 2 times 45. 45, that's 3 times 15. And 15 is 3 times 5. So now we count how many 2's we got. So we got 1, 2, 3. Looks like we got 2 3's. And looks like we're going to have 3 2's, or 2 3's, excuse me. And we got a single little 5 in there. So this, what I have under the square root here, is equivalent to that. Now, what is the purpose of this prime factorization, breaking it down? Well, obviously, as I mentioned, when we put the square root of 360 in the calculator, we get a decimal. So, you know, you're not going to get a whole number, obviously. And so what you can do to simplify the square roots is do prime factorization so that you can find a better value than just saying the square root of 360 or putting the decimal. And so what we can do is break this up a little bit, essentially. So we can break this up as the square root of 2 squared times the square root of 3 squared times the square root of 2 times 5. And notice that's the same thing as that. The only difference is I broke it up a little bit. Now we know that 2 squared is 4. Take the square root of that, we'll get 2. And I'll do it down here. And so if we do that, we'll take the square root, we'll get 2. 3 squared is 9. Take the square root of that, we get 3. And then 2 times 5 is 10. So 2 times 3 is 6. 2 times 5 is 10. So this would be the square root of 10. So that's how you reduce the square root of 360 using prime factorization, which you guys probably know how to do because, you know, you've done that in algebra. So the magnitude of the cross product here is just going to be 6 times the square root of 10. And I guess you could say units if you want. That's our answer. So final answer, our area, which was the magnitude of the cross product, is 6 times the square root of 10 units. Okay. All right. And that's your answer. Oh, one thing I wanted to mention. Notice the distinct difference between the question that we were asked at the beginning. So remember, for the area of the parallelogram, it would just be the magnitude of the cross product of these two vectors. Be careful not to mix that up with if they said to find the area of the triangle. Well, that would just be 1/2 times the magnitude of the cross product of u and v. But we don't have a triangle. It tells us a parallelogram. So we use that formula and not the one for the triangle. So just make sure you don't mix the two up. But other than that, that's your answer. I'll see y'all later.